Well, hello YouTubers, and welcome back to the Holtzmichel channel and this episode of Downward Pressure. Don't really know what else to name this one, but in today's video we're going to be overhauling a set of feed rolls for a Weinig planer matcher. We'll get to looking at some of the damages that were induced to this piece right here. As you can see, the damage is pretty catastrophic. Once we dismantled the part and got to looking at it a little closer, there was hairline fractures all throughout the part. It's essentially a total loss, but since the company doesn't want to invest a whole lot of money in buying a new part, we're just going to go ahead and revamp the old one in the hopes that that'll survive some more. With the repairs that were done to it, I think it should probably outlive me or my successor by quite a large margin, if no other mishaps, shall we say, incur any more damage to the part. But anyway, we're going to start with tearing the part down, like right here. So here's how we're going to get the measurement of the holes. What I did is I took 2 pins that fit the holes exactly, just some cold rolled stock that I had kicking around the shop, happened to fit perfectly, so I just went ahead and just flushed the end, trimmed the ends off a little bit, squared them up on the lathe, stuck them in there, and then took a piece of HSS steel, which is ground and parallel in all dimensions, so it was good enough to use as a reference to establish the distance of the holes from the edge of the top of the part. So here's how we're going to do that. And so getting the distance between the holes, of course, is no big trick. You just stick your pins in, measure in between, and Bob's your uncle. Then you have, of course, add one full dimension or one full diameter of a pin to the measurement you get, and then you have the exact center of your holes. And so we established that the hole distance was 130 by 100 millimeters on a 4-hole pattern, and so there was also a 19 millimeter distance from the top down to the first hole. So that's how we got that measurement. So I just wrote it down on a piece of paper and hung it over there on the parting head, and used that to get that. So, as you can see, the whole thing is a little stiff. It took a little bit more force to get it apart than I would have liked, but nevertheless it came good enough to where now we can take the part and mount it on the table, like right here. The part was machined on 3 sides, so we had pretty good reference surfaces all the way around. So we got to take the flange off the part, the mounting flange, because it just, two of the bottom ears broke off, and then there's hairline cracks all throughout it. So here's how we're going to go ahead and mill off that mounting flange. Step of it is, of course, making the plate. We're going to have to put a new plate on, and it's going to have to be at the same distance, or I should say the same dimension as the original part. And what I had originally intended for was the part was 152 millimeters, so I was going to take off just enough to where the thickness of the plate that I had would have been 1 millimeter left over. Now, things sometimes, little mistakes can work out in your favor sometimes, and this one happened to. My colleague went and ground the plate, took off a little bit too much that I was actually intending to leave, but then he welded the ears onto it, because we're going to insert the ears into the part and pin it and screw it to where it has a good connection. And so when he welded the part, it didn't warp. I was fully expecting some warpage. The piece of steel that we used is an old splitter off of a gang saw, and those are usually made out of spring steel. And so in this instance, that little mistake actually worked out to our benefit. The part stayed flat, at least flat enough to where we didn't have to do any more grinding or milling of the mating surface of the part that goes up against the machine. But anyway, here's how we're going to take a few of the other steps. I realize some of the footage is incomplete. We were in a big rush to get it done, so it was push, 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 and got it done, and it works. But anyway, here's some of the other steps, including the drilling and pinning of the part. Now, what we did is took a piece of just a ground piece of stock and held it to the back of the table of the mill and butted the top of the part up against it. Now, as you can see in one part, it pays to pay attention when you're tapping a hole. I was tapping the screw hole, and my drill chuck bumped into the upper flange of the part and snapped off the tap in the hole. So now I got to get a hold of one of those tap drills and drill that tap out and then put the screw in, but that's for another video later on down the line.
Yeah.
Ja, ist okay. Deswegen habe ich schon jetzt die Ehre zu sprechen. Oh ja, okay. Gut, okay. Ja, ganz gut. Und selber. Oh je. Ja, natürlich ist echt auch besser früh fahren als beim Arbeitsfahren. Ja. Und das war von der Bau und Umgebung. Ja, das war ja, das ist immer wie eine.
Anyway, now here's us putting the part back in with the GoPro. And as you can see, it turned out just fine. Now, like I said before in the intro of the video, with all things considered, if the machine is used in the fashion which it was intended for, even with only 3 screws and 2 pins, there's no reason that part shouldn't survive me or even a successor for that matter. Well, YouTubers, that's a wrap for this episode of Downward Pressure. I hope you guys could glean a few pointers out of today's little lesson. You know, mainly the biggest lesson here is to pay attention to your tap and where your chuck is at. You know, big problem because the chuck that I have for this thing is one from Albrecht and it's self-tightening. So when you encounter resistance, of course, it tightens up, and the tap as it went in encountered some resistance and it tightened up, and then of course as the chuck made contact with the mounting flange, it snapped off because it just couldn't pull the tap out of the chuck because the chuck was so tight that it didn't have any more give to it. So anyway, for those of you following along, I'll probably include some footage later on down the line once we get the machine up and running. As is right now, we've connected everything. It's back. Some of the other damage that was done to the part, the shafts were bent, so they have a little bit of a what do you call it? A bend to the shaft. The pivot shaft was also slightly bent, but since it's a slow roller, that eccentric movement isn't really going to impact the performance of the part in a negative way. This is the first set of infeed rolls that comes into a Weinig planer matcher right over the joiner part of the machine, so it should perform just fine the way it is. So anyway, I hope you guys got something out of it. If you have any questions, comments, thoughts, critiques, suggestions, put them down in the comment section below. And thanks for stopping by, and we'll hope to see you guys again very, very soon.